Hello guys, today we're finally going to cover the machine learning roadmap that I exactly followed to transition my career from a business consultant to the machine learning engineer. This roadmap content is divided into two parts. Please go back and watch part 1 if you have missed it. Let's dive in. Now we're at the phase 3. Phase 3 is where you continue in parallel with the phase 2 and phase 4. This is phase for machine learning competition, and as I've written down here, it's very important. So what you'll be actually learning is this. So Kaggle is one of the machine learning or data science competitions. It's not about winning. You'll never win. I've never won, which is pretty sad. But so joining competition is about reading what winners have done and try to benchmark it, try to see how the machine learning theories that you have learned in the previous phase comes into the real life. How is it applied? How does it affect the decision making of what kind of codes we write? You should be forking the notebooks from Kaggle and try to read them line by line. Try to drill in and study why they made this decision. And this is also a fantastic thing to try. If you are feeling bored and lost and start to come up with these questions, am I doing well? This sounds boring. I don't think I'm moving on. Then it's time to sign up for competitions because every competition has a deadline, right? And this deadline will push you to work so much harder. So I've written down why parallel, not sequential, because the competition is something that'll trigger you to go back to your learnings and see what you have understood and what you have not understood. So the tools you'll be using is actually all the combination of phase 1 and phase 2. As you can see here, scikit-learn, XGBoost, LightGBM, CatBoost, all those kind of evaluation websites, NumPy, Pandas, Polars, Matplotlib, Seaborn, and Plotly. Honestly, this library sounds a lot. I think at first when I was looking at all the libraries that I should be learning, I was like, I can't possibly do this. This is so much. But when you follow step by step, you'll find yourself. You already learned things that you were supposed to. The self-checks you should be doing first. You've made at least one serious submission on the competition. Don't just fork other people's notebook and resubmit. That's a big red flag. You should try to spend time focusing on how can I improve this model and make a submission that will count. And second, you trust your local cross-validation score more than a public leaderboard. This is also related to that you have enough confidence that you have made a right approach based on other people's benchmarking notebooks or bench or your reflections, that your score, your approach that you took is better than other public leaderboard because of the decisions that you have made. Because in this decision making in machine learning, building, development, validation, you need to have enough reasoning. For example, because the domain expert focus on these features, I've put more extra weight here. Or because this model was overfitting too much, I've applied the ensemble or different voting classifier or use transfer learning to make my model more persuasive. The other list you should be taking a look is you've read over 20 top scoring notebooks line by line. All my favorite top scoring notebooks, and I'll just read it like books. I'll just write down randomly on an empty notebook and try to think about why did these people wrote this code like this? What would be reasoning behind that? The other things you finish in the top 50% at least one competition. Try to see, because on a Kaggle, if you submit it, you'll see the leaderboard and you can identify which position you're in. Milestone of here is 2 serious competition submissions and 20 plus top notebooks ready that you read deeply. Try to pick one competition or one or more, the more the merrier, and try to write down some blog posts about how you approached it. So the key resources, my video I've written down because it's my channel. There are some machine learning and data science competition website lists that you can look into. Again, as I've mentioned earlier, don't spend too much time looking for the best resources, right? Try to pick one of the platform. If you don't want to think about it, just start with Kaggle and then sign yourself in for the competition. So I've also the link over here, the Kaggle competition for beginners. One of the other community member have written down. So try to take a look. I've written down here, find a competition that you enjoy and intrigues you. So again, if you're feeling frustrated, not sure if you're doing well, try to do some competitions. Just sign up, face a deadline, and submit. So phase 4 is a difficult part. It's difficult but fascinating part. This is where you should learn the deep learning basics. What we mean by a deep learning is a PyTorch, neural networks, things like this. So deep learning is the basis of everything that we're using lately. GPT, the transformers, large language models, the vision models, generative AI. All the exciting part is here. But this is in the phase 4. Because we have successfully completed phase 1 to phase 3, you're eligible to study deep learning. But this deep learning part, I felt like personally is about 10 times more difficult than machine learning. I'm not trying to scare you, but this phase will humble you. That's why I've written down here. You'll easily face models is not training. You'll suddenly go to NAN. Your data type, data shape is different. Tensors, it feels so unfamiliar, and top doesn't have enough GPU or RAM. You'll run out of memory. Your laptop will go all blown up. You'll feel dumb all the time when I first started deep learning. But you shouldn't quit here because this is the most fun and the part that you can differentiate yourself with other machine learning learners. Here, you'll be able to learn PyTorch. Also have other divisions like Torch Vision, Torch Audio, but I've written down Torch Vision as example. You can also take a look at Hugging Face transformers. What are the other researchers have listed down? You can take a look at Hugging Face datasets, not just Hugging Face in particular, different datasets. Try to look it up, not just well-processed good dataset in Kaggle. Try to look for a real dataset in this phase. The checklist that you should be looking at is you can write a PyTorch or TensorFlow training loop from memory. This includes things like forward pass, loss, backward, optimizer step. These key things that you should keep in mind. If you feel confident and understand what these means, you are ready to move on. One of the things that you'll be able to notice yourself, oh, maybe I know a bit of PyTorch, is when you can read the PyTorch, this neural network module class, and explain it to others about what each layer does. And it's good to do the backpropagation logic by hand at least once. It's very extensive mathematic formulas. I can't really recall it myself now, but it's important that you try it once and try to understand how these formulas are transformed into the PyTorch code. It's quite fascinating to find out how it's connected. The other checklist is you can fine-tune a pre-trained model on your own data set. So this is important because using your own data set means that you know how to deal with real-world constraints. Because in the real world, the data is imperfect, almost 99% imperfect. Data size is not big enough or data is imbalanced. There are so much noise, there are no data. You know how to deal with your own data set means you are eligible for real-world task, right? So the milestone output here is a custom data set or the model that you fine-tuned from a scratch. So try to fine-tune it on a data set you care about. Let's say you're interested in makeup, like a face makeup. Then you can look up for a celebrity face data set and try to play around and create a model out of it. Or you can experiment your music, your scraped Reddit posts, or book reviews, anything that you find it interesting. The common mistake here is you don't really need to train the massive data from scratch. There are many pre-trained models that have already been pre-trained by massive GPU that individuals can't even think about. So try to start with a pre-trained model and move on to the fine-tuning part. That's more realistic and that's what you will be doing when you join the company. The other thing is don't try to do cool stuff first. So what I mean is don't jump to the transformer part without understanding what MLP is. Also, at this stage, I've mentioned weight and biases. On this stage is important for you to be more professional. It is a good habit that you should using the experiment tracking. This is also a very good habit when you join the company. Let's say if you have to report your manager, oh, I've done about 50 experiments, but you can't say, oh, I've done 50 experiments. I kind of forgot what I've did. You should be able to say, oh, among 50 experiments, this result shows this based on this plotting and logging. So try to be more professional in developing this deep learning model.
Okay, the thing I want to emphasize here is you'll never understand PyTorch until you struggle weeks and weeks trying to fine-tune your deep learning model. I think I was on a phase like, oh, there's no way I'm gonna understand this PyTorch. But I spent a couple of months trying to tackle on models. And I've built my own data set. I trained on those data set, built my model, and I was able to consider myself, oh, I know how PyTorch code works. You'll have that aha moment. Try not to be rushed and try to work on your personal projects or competitions, and you'll have those clicking moments. The key resources, I've recently took a video about how I learned Python by comparing with research paper. I think this is really one of the key things that worked for me, so I hope that method works for you. Deep learning part is mostly the last chapters of the machine learning part. So if you have one book that you're already reading, you'll have the deep learning part in the backside. So you don't need to look for new resources here. Just use the book they were learning before. And I've also linked the PyTorch Learn the Basics part. This is one of the official documentation's learning material, which I find quite useful. Now we're at the phase 5. Oh, the video is getting longer than I thought. But in this phase 5, this is the time that you choose your specialty. If you think about AI, we deal with so many different things. You can deal with image, you can deal with video, you can deal with audio, you can deal with numeric data. You need to choose what you are particularly interested in. So it's time to pick your specialty. It's the time that you focus on the depth over breadth. So pick one area. NLP, LLM, computer vision, reinforcement learning, generative AI. Personally, I was most fascinated by computer vision because I liked seeing the results visually. This is time you focus on reading papers, reproduce the results, and slowly try to build your own specialty. So here, I've listed down as tools, but these are more of the paper sources. About the sources of the paper, I've filmed a video about how to read the research paper, which I would highly recommend among my playlist to kind of tactic that really helped me to understand the research papers a lot better and faster. I've also listed down on my blog about the AI research papers for every learners. So please take a look if you're not sure which paper you should be reading. So in this phase, what I did, I remember, I just randomly printed out all the research papers that I want to read and I should be reading. And I just put at one side of my living room. I just read it whenever I had time. I just underlined it and I came back and I read again. I think I printed out about 20 papers. And in the end, I could understand a bit. The things that I couldn't understand at the very first time, you'll get used to it. Just keep reading it and maybe print out some research paper, put it everywhere inside your house and try to pick it up and read it. So when you pass this phase 5, you should be able to name your top 3 specialization, what kind of interest in AI field you have. And also you've read over 5 papers. Third, you reproduce at least one paper's implementation. What I mean one paper's implementation is lately is one of the mandatory prerequisites that all the academia, when they submit the paper, they should also submit the code base implemented in open source. So if you read one paper, try to transform this explanation written down on a research paper into the real code implementation. And fourth is you can explain a recent breakthrough paper to appear. So if you can explain the recent breakthrough, it means you are familiar with the recent trends of the special field that you're interested in. Second, you know how to differentiate the different ideas that the researchers have tweaked. So it means you have insight on the field that you're interested in. The fifth, you're following 5+ researchers in your chosen field. It can be Twitter, it can be LinkedIn, it can be any social media. But try to follow the researchers that you're interested in. You might be able to come across the most recent breakthrough faster than anyone. So the milestone that you read deeply, more than 5 papers, that's good. You can also try to write a blog post that explains your interest, like a Medium blog or any kind of tech blog. So the common mistake is don't try to focus on too many papers too early. Because if you don't understand paper A and then you move on to B, C, D, E, you'll never understand paper A. I would rather recommend you to come back to this paper and then try to understand things that you don't understand in the very beginning. Try to take a look at the resources as I've mentioned earlier. Next is phase 6. This is the final stage. This is a stage that you should be able to build and ship the AI product. This is the most challenging part also because you need to have a background knowledge in a full stack, meaning front-end data engineering cloud service like Google Cloud or Microsoft Azure service. It is very difficult. How would you know the software basics in the very beginning? But because lately Cloud Code Assistant tool is showing the excellent performance, I think this is one of the best time you can try out building your AI product. If you don't know web development, you can make use of a code assistant to build a web and try to develop your own product. So this is a phase that you should be able to prove to people. You know how to turn AI knowledge into something that real people can use. You can leverage, you can try to implement RAG framework. You can define agents, fast API, Docker deployment, MLOps. It sounds difficult, right? I still don't know some of the software engineering key concepts, but while building your own AI products, you'll familiarize yourself. First time using Docker, you'll feel like, oh, what is this Docker? Docker file, Docker definition. But if you use it second time, you'll be able to understand intuitively what it is. While building your API using your own model, you can implement things like fast API, making your own endpoint. If you want to make it easier, you can use things like Streamlit. I know this wouldn't make any sense at this point, but if you continue doing competition or hackathon, you'll know this just naturally. Trust yourself. Don't try to look up and study it one by one. This is something that you should be learning by experience, not by books. And about the cloud service, I think when I first tried to use AWS, Google Cloud, every terminology there didn't make sense to me at all. But while you build a products, AI products, web products, app applications, you'll be able to understand what the role of each service is. You just need more time to understand these. So self-checklist that you should be looking at is first, you can turn a real problem into working AI product. Let's say you're really into stock prediction, like stock market. You're interested in how to increase people's profits in the stock trading. Then you can make your own stock trading website and you can build a model that predicts faster, more accurate than any other models in the world. And then you can put it as a product. And if you find more users, then if you can prove yourself by increasing the users, it means you not only know how to implement and build AI and ship it into a stable product, but also it's a technical product that has demand on it. And this will be your biggest weapon in any of the work experience or any job hunting that you'll be facing in the future. The second is you can connect AI model to the web app API and mobile app. So on the previous phases, when you do like developing model and submit to the competition, it doesn't move on farther, right? It doesn't move on farther to the application part. But this is the part you should pay attention to application. Lately, many job posts, machine learning engineer in particular, are looking for people who have deployment experience. And this deployment experience is directly related to this phase 6. So similar to this deployment experience, you need to experience what CI/CD is. You need to know how to containerize using Docker. You need to know how to monitor the AI performance. Because if you think about AI, some people think AI is something that you set up one time and it's just done. But it doesn't work like that, right? The data set changes, the data set distribution changes. There can be many different shifts that affect the performance of your AI. So the monitoring should also be the part that you should consider in this phase. The other thing is it'll be a big accomplishment if you can gain over 10 users on your product, because that's something that you can prove numerically on your resume or to the interviewer in the future. And the last thing is you can track a cost per user and latency in production. This is more on a production side, and it also shows you that you can view this machine learning pipeline not just on a ML development side, but on a broader perspective. So the milestone that you'll achieve here is you'll have your own web app application with AI functions inside. The AI models, AI API, or the model that you have fine-tuned. So some people might ask, What kind of products do you mean? Like, how can I build things? I'm not sure what I should be building. Then find the problems around you. Find the machine learning problem that you want to solve around. Ask your family, ask your friend, do you have anything that you want me to solve using my AI knowledge? And that's the best way to come up with problems that you are motivated to solve. All those things that I've mentioned here, this end-to-end pipeline that we call MLOps. And it's nice to have this MLOps knowledge if you want to showcase people and want to change your career towards machine learning. So what happens after phase 6? You don't finish this roadmap. Being engineer, any software engineer, machine learning engineer, it means you should keep learning consistently until you retire. From phase 6, it's just continuous process of being a practitioner. You don't graduate from this phase. It doesn't mean that you finish phase 1 to phase 6 and finish, let's say you spent intensive a year and a half. It doesn't mean that, oh, I'm done, I can get this job. It means you're just in the beginning, but you are ready to apply for other positions, career switching that you want to pursue in. I also want to share you this. I've created this AI self-study roadmap for people who want to understand the concepts better. On this mind map, you can unfold it. I've listed down from phase 1 to phase 6. And if you expand it, you'll be able to see what kind of concepts you should be able to focus on. For example, Python for machine learning, the things you should know is a supervised, unsupervised, recommender system, feature engineering, evaluation metrics, applied statistics, machine learning competitions, what kind of things you should pay attention to, the deep learning, what kind of concepts that you'll be learning from, what kind of specialization. So in this specialization, you can see if I expand it farther, you can take a look. In a deep learning, there are different types of deep learning models. For example, CNN has AlexNet, VGG, ResNet, which is very historical but phenomenal models. Sequence models. Try to take a look, scrolling down, what are the things I've listed down. This list is not perfect, but this is good for you to kind of check on. There was one mind map that I really loved, but I couldn't find the link, so I just created on my own. So please take a look. But I don't want you to be terrified looking at all these lists and say, when am I going to finish it? I told you as before, try to focus on phase 1 by 1. And in a few months, you'll find yourself, you'll learn things that you were hoping to learn in the end. All these long list of things.
The last thing that I want to share today is about the checklist written by Emil Wallner. This is a checklist that I used to paste on one side of my wall and try to read it every single day and help me to remind myself, am I ready? Am I good enough right now? So these are the checklists that he has listed down. He say if you pick any 3 of them and if you meet those standards, it means it can be equivalent to the self-taught machine learning degree. The first thing is being in top 20 in machine learning competition. It makes sense because if you can be inside top 20 machine learning competition, most of the ML competition is global, right? So if you can be within top 20, it means you're good enough. It means you know how to make a good model. It means how you can evaluate and train the model properly, because most of the competition you need to go through the code review, and it means your code quality of the code is proven. And second is publishing a research paper. This is not really a common thing that happen, but I've heard some cases, even you're not inside master's or PhD degree, you can publish your paper. If you have a particular interest that you want to drill in, you can start writing your paper, submit to some big academias that you can prove yourself in a research aspect. And third is doing a machine learning consulting gig or a contract job. It can be something like a freelancing job. When people ask me, oh, it's very difficult to look for a job opportunity, especially if you are changing your career. One thing I would advise to people is start your freelancing job. I've seen one of my friends, he started his own data science freelancing job, and he gained many reviews about his data science, machine learning modeling, and got a good feedback. And this became a good work experience for him. So if nobody gives you a chance, try to make your own chance by doing a freelancing job or signing up for a contract job. And the third and fourth is creating AI writing about gaining over 50K readers or having over 30K view on the video. I think this is more an aspect that you're eligible enough to explain the concepts that you have about your AI knowledge. I think this part is more about your AI knowledge delivery. And if you also for me, if whenever I prepare the contents, you need to study a lot to deliver in a fact base and help people to understand better. So I think this is quite good option that you can try out. The other one is creating a machine learning tool with over 100 weekly users. This is also great. I think I would highly recommend this one at this point, because if you look at machine learning engineer job posts, many of them are requesting for people who have deployment experience, who have productionized experience, which means that if you create a model that just sits inside your laptop, it wouldn't be competitive anymore. You need to show on a public and see people's reaction and bring your model into the actual value. The other thing is mastering part 1 of Ian Goodfellow's deep learning book. This is one of my favorite deep learning books. You can easily download the PDF version from Google. This is great because part 1, it has all the condensed foundational knowledge that you need to know if you want to understand any machine learning or the deep learning concepts. The last thing is creating the merge pull request for the TensorFlow or PyTorch. Creating a pull request itself is not too difficult, but if you get accepted on a merge pull request, this is a big thing. I've heard of some stories in Reddit. If you submit a good PR request and if you get a merge, you might be able to get some job opportunity like internship, contract, or job trials. Because merging pull requests, it indicates that you know how to catch the problem that is causing bugs inside this repository, and you know how to solve it because you have proposed it. And if your code is functioning well, and because they go through internal code review, and then they run some tests. But if it works well, it means you can write a good code that thousands, millions of people use. The very last advice that I want to share is stay hungry and seek for every opportunity that you can grab. I think for me, one of the biggest things that I felt desperate and really devastated about was no one was giving me any chances. I even thought like, how can they not give me any opportunities? I think I'm good enough. But that's the thing about career switching. It's not easy. You need to ask anyone you know if there's any opportunity, your professors in uni or your friends. Keep appealing and growing your skill and tell them, I'm looking for this opportunity. I want this. I want to finish today's video with my favorite phrase, which is also pasted on one side of my wall all the time. It's called the never underestimate yourself. It's one of the things that really empowered me to not give up and consistently push this career path and land in this job. It's not easy, but I'm really happy that I switched my career. I'm really happy being part of this big change that is changing every part of everyone's life called AI. Hope you have a good day. And if you're interested in any AI trend or want to learn AI better, please subscribe and like. Thank you.